Good morning, guys. Anjani Kumar here, dealing instrumentation subject for final year electrical students. In the last session, we started transducer, right? And what we discussed in the last session means we just started transducer. Right? So, what is the definition of a transducer? The transducer is a device which converts non-electrical quantity into electrical quantity. Right? So the transducer is a device which converts non-electrical quantity into electrical quantity. So it is not mandatory to convert electrical quantity. So any form, non-electrical quantity is nothing but energy, one form of energy. This is another form of energy. So it's also a device which converts one form of energy to another form of energy. Right? Basically, we require electrical supply. We require my output as electrical. So why? Because it should be used for other instruments to work, other controls to work, other systems to work. So that's why each and every time we are getting electrical output. That is our requirement. That's why we are converting our non-electrical quantity into electrical energy. Right? So, so this is the definition of a transducer, and we discussed about some examples why the transducer, how the transducers are working means mercury thermometer. Alright, we discussed about a manometer. Right, in detail, right? Mercury thermometer, how the temperature variations in a room, how we can calculate. We don't have any methods to calculate this one. That means the linear displacement of mercury, it can represent the temperature variations. That means linear displacement which is converted to temperature. That means non-electrical quantity which is converted to another form of energy, right? And after that manometer, the pressure, you don't have any methods to find out the pressure. So there is a transducer, manometer transducer will work how to find the pressure. That means linear displacement of the water level which represents the pressure of a liquid. So how in detail we discussed about two examples also. In today's session we are going to discuss about what are the parts in a transducer and characteristics of a transducer. Right? These are very, very important concepts. So it's better to follow my videos. Right? Now we'll discuss about parts of a transducer. Right? So the transducer is a device which is having two parts. The first one is sensor. Right? Second one is transduction element. Right? So the transducer is a device which is having how many parts? Two parts. Those are a sensor and transduction element. Now we'll discuss how the block diagram of a transducer. This is a sensing element. This is a transduction, which is my input. This is my output. So this is the block diagram of a transducer. So which is having how many parts? Which is having two parts. That is called a sensing element, and another one is a transduction element. So the input which is a non-electrical quantity. Right? So the sensing element which sense the what type of input it is, that is nothing but which sense the signal. So whether the signal is non-electrical quantity or not, it will sense. So like with the help of sensors, right? After that, the signal will be entered into the transduction element. So the transduction element, which is very very important part in the transducer, which converts that non-electrical quantity into other form of energy. Like it's not a requirement of electrical, right? It's not the electrical, but basically whatever the electronic instruments that are we are using now with the help of electrical signal like voltage and current. So that's why we are converting our non-electrical quantity into electrical quantity. That's our issue, right? So the transduction elements is the main part which converts non-electrical quantity into electrical quantity. So if it is electrical quantity, we can call it as electrical transducer. If it is a mechanical quantity, we can call it as a mechanical transducer, right? We discuss about different types of a transducer concepts, right? Or any form. Energy. So the main important point in a transducer is a transduction element, right? How many parts in a transducer? Transducer which is having two parts. The first one is a sensor and the second one is a transduction element. So what is the function of a sensor? Sensor will sense the signal. That means will identify how much physical quantity it is, right? What type of quantity it is, right? Then that signal will be sent to the transduction element. So the transduction element is the main part in a transducer which converts non-electrical quantity into electrical quantity or any form of energy. So the basic function of a transducer. So this is about the different parts of a transducer. But in some sort of transducer, we don't have any sensor, right? Right. Some type of transducers, so we don't have any sensor, right? So we don't have any sensor. The transduction element will act as a sensor out there. That means I'll discuss about example of how the transduction element will work as a sensor itself. Right? So that's why all the sensor elements, very very important note that you have to note it down. It means all the sensors are transducers. Very very important. But all the transducers may not be sensor. Right? Very very important concept. Very very important note that definitely will get the question in the last polytechnic exams that we got these type of questions. True or false, no? Right? So that means each and every transducer, it's not having any sensor. Maybe it may have, may not. Right? Some types of transducer, we don't have any sensor. So only transduction element will be present that will act as both sensor and a transducer. Right? So what is the note? All that's why from this statement only we are deriving this statement. That means all the sensors are transducers, but all the transducers may not be sensor. Right? Some other types of a transducer we are not use these type of sensors. The transduction element will act as a sensor. So what are that one? So those are thermocouples. So those are thermocouple. So what is a thermocouple? thermocouple which gives a temperature into electrical energy. So that thermocouple is a transducer which converts how much temperature present in the system, how much heat generated in the system, that can be calculated. We don't have any methods to find out the heat present in the system. So that we'll discuss later different types of transducers. Alright, so how the thermocouple work means, two dissimilar materials, the two dissimilar materials that are joined together and will make a change in temperature, it will generate the heat. So that heat can be calculated into electrical energy. This will explain clear. These are two dissimilar materials. It means different materials which are joined together, and we are applying temperature. That means we are applying heat. So how it will have at 0 degrees centigrade we are applying heat, and after that some other 15 degrees centigrade. Right? So these two things are going to be heated. Then definitely there will be heat will be generated. Heat will be generated. This heat will be converted into electrical energy. So that means non-electrical quantity, which is heat generated, change in temperature, right? Once we are using 0 degree centigrade, we just apply a 0 degree centigrade over there, and after that 15 degree centigrade, there will be a temperature difference. There will be a heat will be generated. The heat will be converted into electrical energy. Here we don't have any sensor. Right, whatever the non-electrical quantity, which is heat, directly converted to electrical quantity. So this is one of the examples that we don't have any sensors in this type of thermocouples, right? So what is a thermocouple? Thermocouple means two dissimilar materials that are joined together. The change in temperatures, that means heat is generated. That heat is converted into electrical energy. Right? The temperature differences will generate the heat. That heat is converted to electrical energy. So that means one non-electrical quantity which is converted to electrical quantity. So that's why these thermocouple we can call it as a transducer. Right? Each and every transducer, the definition is a non-electrical quantity which is converted to electrical quantity. I hope it's clear how the thermocouple will work. There are two dissimilar materials that are joined together and apply change in temperature. So for a first 0 degree centigrade, for a first 15 degree centigrade. That means this change in temperature will generate the heat at the junction of two dissimilar metals. So this heat that we are converted to electrical energy. So that means we don't have any sensor over here. So that's why these type of elements are not required sensors, right? And we'll discuss about real life examples of a transducer. So after that we'll discuss about characteristics of a transducer, right? The first one is thermometer. Thermometer, if you want to find the temperature of a body, so we don't have any methods to calculate the temperature of a body, so we require a device called a thermometer. So how it will work? మనం ఎప్పుడైతే దాని నోట్లో పెట్టుకుంటామో, what happened, the mercury in that meter will move the linear displacement, so which is having some readings na. Right? So these are the temperature readings. Right? So the mercury will be placed into here. Right? So we don't have any direct method to find the temperature of a body. So what happened, whenever this type of thermometer put in your mouth, definitely your mercury will change your levels, right? Change your displacement. So what happened, ఎప్పుడైతే పెట్టుకుంటామో దీని levels will be changed. So levels change అయినప్పుడు you can easily identify the temperature, right? That means displacement which is converted to temperature. One form of energy which is converted to another form of energy. So this is like a transducer. right? Or second one is electrical bulb. Electrical bulb, so which converts electrical energy into optical energy, right? So it converts electrical energy into optical energy. It's nothing but one form of energy into another form of energy. After that, electric motor. So electric motor which converts electrical energy into mechanical energy. It's like a transducer, so it is a mechanical transducer. Or generator, which converts mechanical energy to electrical energy. So this is called electrical transducer. Non-electrical quantity. So where the positions requirement is there, but we don't have that much concept is that what giving input, how we are getting the output, what type of output that you are getting. So that is our concentration, right? So that's why we have a mechanical input that can be converted to electrical inputs. That means it is an electrical transducer. So these are basic real life examples that we are using. Different sensors is there. Each and every sensor is a transducer, right? Different sensors that are we will go in that will use these type of sensors in experiments, research laboratories, right? All these things we require these type of transducer. All sensor is nothing but a transducer, but every transducer may not be a sensor. So this is very important statements that we discussed here, right? So this is about what is a transducer and what are the different parts of a transducer, why we need a transducer, right? There is a conversion for a non-electrical quantity into electrical quantity, so we require a device. So that device we can call it as a transducer, right? And we discussed about different types of examples also. Okay, I hope it's clear. Now we'll enter into the characteristics of a transducer. Correct. So what are the characteristics of it? Why we require these type of characteristics in for a transducer? That means transducer is nothing but a sensor, na? Right? So if you are doing an experiment, right? We require a sensor, right? What type of sensor that you are going to choose? So if you are in a research laboratory, right? You are doing an experiment, right? So in that experiment we require non-electrical quantity, whatever the pressure or a temperature, liquid flow, so that we need to convert into electrical energy, so that we require a transducer. So you have a choice. You have to know what type of transducer which may be used for this experiment, right? So how you can, what type of transducer I'll get good results, 100% results, right? The choice must be depends on the characteristics of a transducer. That means while doing experiments or research laboratories or change of sensors, because sensors are very costly equipment, right? Costly devices, right? For choice of a sensor, it is important to what type of characteristic it has. So then only those type of sensors also we have to take it and do the experiments, right? Then only you'll get the good results. So that's why the characteristics of some sensors must be used to find out which type of sensor can be used for an experiment, right? So basically there are two types of characteristics. So if you clearly understand my previous lectures, like characteristics of instruments, so that a sensor or a transducer is nothing but an instrument, right? So if you clearly understand that concepts, we don't have to study of these characteristics, but the same characteristics will be repeated here, because the transducer instrument, each and every instrument that it has static characteristics, and dynamic characteristics. Same characteristics will repeat it here. Why? Because the transducer is nothing but an instrument. Alright, the same characteristics will implement here also. But I just want to give a brief review on these two type of characteristics. Right? So what is a static characteristics? It doesn't depends on a time. But suppose if you are giving a input, the output that we are getting it's in a static condition. So output in a static condition. It means my output doesn't depends on input variations. Got it now? My output is in a static condition. So my output doesn't depends upon how your input varies with the time and all these things, right? So dynamic characteristics means the output in a dynamic condition. That means output must depends on the time variation of input. Right? So this is a dynamic characteristics. Right? How many characteristics of instrument? Why we require a characteristics means the best choice while selecting a sensor, while selecting a transducer, we require a characteristics. So with that you have to take these type of transducers. With the help of these type of transducers, we'll get 100% results. That's why characteristics plays a predominant role in a transducer. While selecting is an important issue. So doing experiment is nothing. So what type of transducers we are selecting is very important. That depends on the characteristics of a transducer. Right? Basically there are two types of characteristics, static characteristics and dynamic characteristics. So what is the static characteristics? Whatever the output, that is in a static condition. It doesn't depends on input or time variations, right? Input variations may depend kaadu. So what is a dynamic characteristics? Dynamic characteristic means the output which depends on our input variations with respect to time. So these are the dynamic characteristics. Now we'll discuss each and every characteristics individually. So, right? I already explained with neat examples under first unit different characteristics of instruments. So that's why we don't have that much study on this characteristics. I'll give a brief thing. Right? First I'll write the characteristics and explain briefly, right? Static characteristics. Static characteristics are two types. So desirable. Second one is undesirable. So desirable means we require these type of characteristics in the instrument, right? So undesirable means you won't expect these type of characteristics in the instrument. If it happens, definitely the instrument will reach an error value, right? Or instrument may be damaged also. Alright. So what are the static characteristics? First one is accuracy, precision, resolution, linearity, sensitivity. Same characteristics will repeat because a transducer is nothing but an instrument. Sensor is nothing but instruments. Sixth one is repeatability, reproducibility, and a range, spam. Right? So these are desirable characteristics. These are desirable. That means we require these type of characteristics in an instrument. And hysteresis, right? Drift, dead zone, dead time, threshold. So these are undesirable characteristics. Hysteresis, drift, dead zone, dead time, threshold. We discussed all these things, but we have to rewind in this transducer concept itself. Alright. So what are the desirable characteristics? Accuracy, precision, resolution, linearity, sensitivity, repeatability, reproducibility, range, span. So what are undesirable characteristics? Hysteresis, drift. In this drift you have a zero drift, zonal drift, span drift, all these things. Now dead zone, dead time, threshold. These are undesirable characteristics. I'll explain one by one. Just briefly, we already discussed with different examples itself, right? So we don't have that much discussion over here. So what is accuracy? Accuracy means a degree of closeness to the measured value, to the true value. We can call it as accuracy. But suppose if I want to measure 5 volts, so it is my true value. Right, 5 volts measure chela. So that is a true value. I have an instrument. So instrument is 0 to 10 volts instruments తీసుకుంటున్నావు. నువ్వు మెజర్ చేసావు. You are getting the result of 4 volts. So that is called a measured value. Right? The degree of closeness. So 5 volts minus 4 volts, that is nothing but 1 volts is nothing but accuracy. Right? So the accuracy that can be specified in plus or minus error, right? Plus or minus 1% is an accuracy. So degree of closeness, how much close for a measured value to the true value, we can call it as the accuracy of that instrument. So for this instrument, for finding 5 volts, the accuracy is 4 volts. The accuracy is 1 volts. Right? Accuracy can be expressed in terms of full scale. That means plus or minus 1% accuracy on 10 volts scale, or plus or minus 1% accuracy on 5 volts measurement. So these are the two things that we discussed in our last sessions, in previous sessions, right? So this is about accuracy. What is a precision? Precision means consistency in the result. So suppose if you want to find out 5 volts, right? You have a 0 to 10 volts instrument. Right? Each and every time you are getting a result as 2 volts, 2 volts, 2 volts. That means the consistency in an output. So this is called highly precise instrument. Right? Another instrument we have a 0 to 10 volts. It will give us a result 4.1, 4.2, 4.3, 4.4, 4.5. That is meant doesn't have any consistency. This is low precise instrument. Low precise instrument, high precise instrument. So what about the accuracy here? Very high accuracy. What is the accuracy? Is very low accuracy. That means all precise instrument may not be accurate, but all accurate instrument may be precise. So this is very, very important. But suppose this value is 4.9, 4.9, 4.9, 4.9, 4.9. This is a high precision. That means high precision, high accuracy. That means all accurate instrument may be precise, but all precise instrument may not be accurate. This is very, very important statement that we discussed in your previous sessions also. Alright. Now we'll discuss about what is a resolution. A resolution means the smallest change in the instrument that we need to detect. So that we can call it as a resolution. How you can calculate the resolution means. But suppose I have a scale is like this. Right? So my scale which is having a 0, 10, which is having a 2, which is having 4, 6, 8. Right? My pointer starts here. If my pointer stays here, what is that value? You don't know. There is a smallest change. You blindly won't say that is a 2.6, 2.3. You just have to accurately, you have to tell accurately what is that value. This is the smallest change that we need to detect. So that is called a resolution instrument. So for that resolution, we have a number of divisions. So you just place a number of divisions over here. Right? So for this, each and every division, you know the resoluted value. But suppose this division, the point over here, this is a 0.4. So what is that value? This is a third step. That means 2.8. So this is accurate value. So this is the resolution of that instrument. Right? What is that scale? Full scale by number of division. Number of divisions by full scale. So there is a number of divisions 5, 5, 10, 15, 20, 25. Right? So what is the number of divisions? 25 by 10. Number of divisions by full scale. So 25 by 10. Each division represents 2.5. 0.5.